Okay.
1, 2. Now.
Go. Mm-hmm.
Okay. This is going to be a dry ice bubble. Now, to explain how it doesn't make it a bubble. Question that. Because it has chemicals inside first, and there's
Dry ice.
Dry ice in there.
Makes carbon dioxide.
And carbon dioxide. And you'll need dry ice. You'll get it from Food City. And you'll need maybe any kind of water you want. And then when you drop the dry ice in here, it will look like this. And then you'll need this. Soak water with a cloth. Now it's got to be real soaky so it can work. Now, we squeeze this. Now we're going to do it around the edges. And make sure you don't drop it in. You should do it 2 or 3 times. Now, just make it a soaky again. Now, here comes the fun part. You will have to make this flat. Then you will have to come over here. And then you slightly come over here. And then sit down and watch the fun. And this little chemical bubble is about to become bigger and bigger and bigger. And then soon as it touches one of these edges, which any kind of side, and then it will explode. It's going to be really cool. Now watch the explosion. Becoming huge now. Wow. This one pop. I think it wants to stay alive. Oh. It's on the edge of my side, and poof. And that's how I make the dry ice bubble. Now, bye.
We've already cut some strips of lead and polished them with the steel wool so that we can see them if they react. And you see the lead, it's very soft metal. We got that from roof flashing material. And the same way we got copper strips. And we polished that with steel wool to make sure that we could see any kind of reaction. We also set up some test tubes with galvanized steel nails. So the galvanized is the zinc coating on the outside of the nail. We got 3 of those and little pieces of lead to help us get them in and out. Set up, one over here. We have prepared a solution of 0.2 molar copper sulfate, and we're going to add 3 milliliters to that in a moment, to each tube for each section of the experiment. Let me show you now what we expect to happen. It's always good to get an idea of what you expect to happen before you do the experiment. We already checked the activities of the 3 metals we're using, the zinc, the lead, and the copper, and we found that the zinc is more active a metal than either copper or lead. Lead is more active than copper. So in our experiments we should see zinc replacing the lead and being oxidized to zinc nitrate and leaving lead metal in the atomic form. The same way we expect zinc to replace copper sulfate and become zinc sulfate plus 2. And we expect lead to replace the copper sulfate as well. Okay, we have 3 solutions: the copper sulfate, lead nitrate, and zinc chloride. And we're going to add 3 milliliters of each. I'm sorry, I wanted you to see the table. We're also going to keep track of what happens and put in our observations in these rectangles as we go. This will probably help you in your home experiment. Okay, this is the first time we're running through this experiment, and I hope you remember what to do here. It says to add 3 milliliters of copper sulfate to the first set of test tubes. There's one there for the copper sulfate there. We haven't added the lead here yet. To the second tube, put the lead in so we can see it. If it reacts, make sure we have a full 3 milliliters. A little bit short there, we'll add a few more drops later. Whoop, right down the outside of the tube. We haven't done this yet, this is the first run. You can see change already on the lead. I believe we can. And this should be more reactive than the zinc. The copper sulfate is, put some more in there, and a few drops more in here. You see sort of something on the lead. Alright, let's put the lead into our second set. And make sure we have the shiny side out here. The copper. And this will be the lead nitrate. Lead nitrate solution. Should come with your kit actually. That's where we got it. We got it out of a kit. Ooh. About 3 milliliters into each tube. It's hard to squeeze this. And so we don't forget, we can see the copper sulfate because it's blue, but we can't see the lead nitrate. So we're going to put the lead nitrate bottle in front of the 3 samples. And we're going to put lead and copper strips into the other test tubes. Ooh. Don't have any more test tube rack. And we're going to try the zinc chloride solution in those 3. Boy, not so easy squeezing from these little bottles. We're only getting about 1.5 milliliters for this run. We're going to look at it initially and see if there's been any change right away. I don't see any in the zinc chloride. There's not supposed to be any in there. But I see something on the lead over here. It looks like it's blackened. And the lead here doesn't seem to have reacted. I don't see anything happening with the copper. We're supposed to wait now for 5 to 12 minutes. And just checking the time. 5 to 10 minutes. So we'll check the watch. It's 5 minutes past 1. We'll give it a good 10 minutes. Okay, that's just about 10 minutes. You can see. And we're going to now inspect our materials and make our recordings, our observations, and record it. Here we're going to do the copper sulfate first, which is the copper 2+ solution. We're going to fill those in now. First we're going to look at it. Here's a piece of copper. Nothing has happened to the copper. First glance. Here's the lead. You can see the lead is really brown. It's darkened quite a bit. And here's the galvanized now. And I actually don't see much change in that. We'll compare them with the bright copper. It hasn't been treated at all. And the lead, and you can see the lead has really changed. And the galvanized nail, there's some darkening on the galvanized nail, not much. So we're going to write that in. I'll give you a close-up first. How close we can get without losing focus here. So you can see those. Alright, then we're going to go over to our whiteboard and we're going to put in our observations. The copper, no change, so we'll put NR. NR, it's hard to write like that, for no reaction. Like that. Ooh, can't write in this position. The lead darkened. Darkened. So the lead has reacted here, and it's been oxidized. And the zinc, slight change. Slightly dark. Boy. Okay? Hard to read that, I imagine. Let's take a look now at the lead nitrate samples. See what they look like. Let's put these away. Pull out the copper from the lead nitrate. Again, nothing really. We didn't expect that. And again, we shouldn't have had anything here, lead nitrate, because that's lead, it shouldn't have reacted. But the zinc should have, and it's very slight. So we have an oddity. We have an oddity. I'll write our results in. We'll try and figure out why that happened later. For the lead nitrate, we're not supposed to have any reaction. We had no reaction for the copper, that's proper. But the lead actually darkened. We're supposed to have no reaction there. And the zinc, hardly any, very slight darkening, if you can read that. Very slight darkening, okay? I'll take a look at the other zinc nitrate. Zinc chloride, actually. I don't know why that happened. There's supposed to be no reaction here. So I'll put a question mark next to it. Remember that. Wonder why that happened. You always write down your exact observations. I want to look at the other one. Move these away. And a sample galvanized nail. And we'll look at them. Here, on a close-up. Copper. Again, no reaction. We expected that. The lead. This is in the zinc solution. This time, no reaction. And the zinc should have had a no reaction, but you know, where's the pale? This is the untreated nail. Again, very, very slight. Shouldn't have happened there. This is expected, no reaction. Let me turn the camera so you can see the board. Sorry for swinging it that quickly. The next lead was no reaction, that's correct. We expected that also. And the last one was maybe slight reaction. So there you have it. For your table, when you fill it out, the copper sulfate, no reaction with the copper metal. The lead sulfate, the solid lead, reacted, darkened anyhow, and the zinc slightly darkened. So we expected that. If you look up here, we expected the lead to react with the copper lead to react with the copper sulfate. We expected the zinc to react with the copper sulfate. Both of them were oxidized. Okay? But we did not expect the copper to react with the copper sulfate, and that's what we got. Everything's fine so far. But our second set of observations with the zinc, the lead nitrate, 2.2 molar lead nitrate, which is in the bottle labeled like that. I'm checking now to see maybe something's wrong with the materials. This is right. Copper should not have reacted. But somehow the solid lead darkened. We don't know why. And the zinc again very slightly darkened. So the zinc might have reacted a little bit, and it should have. Okay, it bears out what our theory was. And on the last set of samples, we have no reaction with the copper, which we should have had. No reaction with the lead, finally, which we should have. And maybe a tiny little bit with the zinc, and that shouldn't have happened either. So, you know, this is largely no reaction. So the zincs are probably, okay? I mean, that's figuring backwards, but we have exactly what we expected to happen, except for the lead, which darkened on the lead nitrate solution. Right now I have no idea why that occurred. But you can report these results. We're actually supposed to have no reaction here. This is supposed to be no reaction. But we had a reaction. And here it is. You can see it right there on the edge. The darkened lead down the bottom.
As part of our homeschool science lesson, we're going to do an experiment with bean plants. We planted seeds in 2 places, and we're using cottage cheese containers to hold the bean plants. We're going to cover one pot with a box. Another pot we're going to leave out in the sunlight. And then we're going to compare the 2 plants after about 10 days. Okay, so this plant we're going to put a box over for about 10 days. And this one we'll let stay out in the sun. And we'll come back in about 10 days and see how that looks different. So we're using a brick to weigh down each corner of the box, or each side of the box. Hopefully that will prevent the wind from blowing the box away. So there's a green bean plant growing inside the box, and there's one growing outside the box. We want to see what the effect of sunlight is on these plants. Well, today we're going to compare the green bean plants, the one that was in the box for about 12 days and the one that was not in the box. There's 3 green bean plants growing in this old cottage cheese container. Alright. Yeah, go ahead and take off the bricks and take the box off. Let's see what that plant looks like. The one that has not been in the sun. It'll be interesting to see what it looks like.
Okay.
Well, what do you think? Does it look any different?
Yeah, it kind of does. Oh yeah, this leaf is kind of turning yellow, see?
Alright. I'll take this one and put it next to the other one.
Well, this one looks really green and it looks like it has really good leaves. This one has kind of yellow leaves.
Looks like it's dying, doesn't it?
Yeah, it looks like that one's dying. It's got some holes in the leaves too.
Yeah, this leaf definitely looks yellow.
Yeah.
Compared to this one, which is green.
Yeah, this one looks better than that one.
That leaf is dying.
That
leaf really turned yellow and limpy, and the soil looks damp though. Some weeds have germinated here. It's interesting.
Weird. I wonder what. Oh, I can still see the seed attached to them.
Yeah, these plants are definitely not doing good.
Yeah.
But it's not completely dead. Now if we leave it out in the sun, it might come back to life. But the ones that got sunlight all these 12 days, none of their leaves are yellow. They're all green.
Yeah. It also looks like there's more leaves on that one than that one.
Yeah. So what do you think? This plants definitely need sunlight, right?
Yeah.
Plants cannot live without light. I think we should transplant the plants in our garden now. You want to?
Yeah.
Yeah. There's another green bean vine. Letting the beans grow out and grow their seeds. We're going to save the seeds on these. Of course you can eat the seeds, the bean seeds too. Now can you come up here and show the viewer the roots in there?
Yeah, look at those roots.
Saw a grub come out.
Ugh.
There's a grub, can you see that?
Ugh, yeah, I can.
The little guy was hurting on this plant.
Ugh, that's
I'm gonna throw him. Alright. Okay, so now we'll just go ahead and put the green beans in there and oh, I see a worm too. He's covered up already. Okay, we're getting some rainwater. Compliments of God. All right. Here are the green beans that were in the box that didn't get the sunlight. We just took it out of the pot and we noticed the roots are not nearly as developed as the other plant. The roots look a lot smaller. Alright, now we have both pots of green beans transplanted into the garden. What we learned in this science experiment is that plants have to have sunlight in order to be healthy, in order to have healthy leaves, and to have healthy roots. So the roots on the plant that didn't get much sunlight is not nearly as healthy. Alright. Some days have passed. Let's take a look at the green beans now, the green bean plants. The plant on the left is the one that had all the sunlight, and the one on the right here was the one that did not get the sunlight. It was covered with the cardboard box, and it's obvious which one fared better. This science experiment really shows that sunlight is important for plants. We had planted multiple seeds in the cups, or in those pots, and it looks like a couple of them died. They just could not recover after being without sunlight that long. One plant looks like it's going to survive, struggling to live there. But the one that had sunlight all those days is doing pretty well. The leaves are kind of yellow. We've had some very cold nights here. This is November 1st. So actually it's pretty amazing that those plants are even alive. Here's some older bean vines on the trellis. I'm leaving the pods here to dry out, and so I can save the beans that are inside, the dry beans. Here's a pod that's dried out. Should have dry beans inside, and here's another one. As this experiment shows, the sun is very important for life.